This is a Bishop of Llandaff numeracy support video on how to divide. What is dividing? Well, dividing is counting in a number, and we're used to counting in certain numbers. So if we use a number line just to represent that, we're used to counting in ones, so 0, 1, 2, 3, 4, and so on. In terms of dividing, if I was dividing by 2, then what I'm doing is I'm counting in 2's instead of counting in 1's. Now number lines must always start at 0, but now I'm counting in 2's. Instead of going 1, I go 2, 4, 6, 8, and so on. So if I was asked the question, what is 8 divided by 2? Then I'd say, if I'm counting in 2's, how many times can I count in 2 until I arrive at 8? So if I was to look at that on the number line, I would jump from 0 to 2 once, twice, 3 times, 4 times. So I can count in 2's 4 times until I reach 8. Things to be careful of here that our students sometimes get wrong is they count the numbers. They say there's 1, 2, 3, 4, 5 numbers. So the answer is 5, but it's not. It's the number of jumps between each numbers. So for the jump from 0 to 2 would count as 1, then 2, then 3, then 4. If I had a real life problem, say I had £16 and I saw this offer in Tesco or any other supermarket, and I thought, right, £3 each, I have £16, how many can I afford to buy? If I go up to the checkout with £16 and I want to buy as many as possible, then I can afford to buy 1 pack, 2 packs, 3 packs, 4 packs, and a 5th pack. Now, my £16 actually gives me slightly more, but I couldn't just say, oh, can I have 6 packs? It's only £1. I've only got £1. Can I have another pack? They're going to say, no, you have to have the 5 packs and you'll have a £1 change. So you should never move on from this number line. You always go back to what you had originally, and then that number that we landed on, the 15 to 16, the difference between those two is what we call our remainders. So I could buy 5 packs and have a remaining £1. In terms of dividing using the bus stop method, what I would look at doing is saying something like 4,325 divided by 5. Now, as soon as I'm saying I'm dividing by 5, then that means I'm counting 5. So I always start my number line at 0 and then count in 5's. The number that you should stop at is always 10 times the number you were dividing by. There's no need to go any further then, as it is a waste of time. You don't need to have those numbers worked out. So I'd stop in this case at 50. If I'm doing 4,325 divided by 5, that means I want 5 outside what we call our bus shelter. And then the 4,325 would go inside the bus shelter. You should always leave a little bit of room in between these, as you're more than likely going to get remainders. So the first question I'm asking, how many times can I count in 5 till I get to 4? Well, if I look at my number line, 4 is here. I can't even count once in 5 until I get to 4. It's not going to happen. So the answer is 0. I can't count in 5 until I get to 4. In fact, if this number here is ever smaller than the number on the outside, the first answer will be 0. Now we cross that out and bring that across as a remainder. So this is no longer a 3, it's 43. So 43 being by here, I'm now counting how many 5's I can count in until I get to 43. So that's 1, 2, 3, 4, 5, 6, 7, 8 and a bit. So my answer is 8. But 43 to 40 gives me a distance of 3. So that 3 comes with a 2. So it's no longer 2, it's 32. So now looking for 32, which would be here, I would count how many times I can count in 5. So that's 1, 2, 3, 4, 5, 6 and a bit. 6 and 2 remaining. So I'd now bring that 2 across as a remainder, and now I'm looking for 25. So how many times can I count in 5 till I get to 25? 1, 2, 3, 4, and 5 times. So my answer is 865. No need to say that 0 in front of the number. The bus stop works for any numbers, and sometimes you can get remainders. But we'll have another practice at doing one similar to that. If I had 414 and I wanted to divide that by 3, then the divide by 3 means I'm counting threes. So I need to start my number line at 0 and count in threes, all the way until 10 times that number. Now to set this out in the bus stop, the divided by, the smaller number, or what tends to be the smaller number, would come in here, and the 414 would go in here. So if I was to divide that now, I'm counting how many threes until I get to 4. Well, 4 would land here, so that's certainly one jump, but it's 1 and a bit. So the 1 goes there, and between 3 and 4 is a difference of 1. So I have a remainder of 1, which goes there. So that number is no longer 1, it is now 11. So looking for 11, that would land here. That is a number of 1, 2, 3 jumps, 3 and a bit jumps. So I write down 3 jumps, and then 9 to 11 would be a difference of 2. So that would now go with the 4 to make 24. Finally, I'd look at how many 3's go into 24. So 1, 2, 3, 4, 5, 6, 7, 8 jumps. So the answer is 138. You can even use this method when it comes to doing decimals. So if I had a question such as 7.24 divided by 2, I would count in 2's because fundamentally I'm dividing by 2's. So start your number line at 0, then 2, 4, 6. Oh, mistake there on my part, getting too carried away. 2, 4, 6, 8, 10, and so on. Again, stopping at 10 times that number. You'll never go further than 10 times that number. The 2 will go on the outside. The bus stop would start by here and go across, and 7.24 would come in here. Now that decimal point must be lined up above in our answer also. It's very important that you take time to do that at the start. So, first question, how many times can I count in 2 till I arrive at 7? Well, 7 would be here, so that is 1, 2, 3 times. So I can count in 3 times in 2 until I get 7, but I really get to 6 and I have 1 remaining. So that goes with the 2 and becomes 12. From there, I'm counting how many times can I count in 2 till I get to 12. So that's 1, 2, 3, 4, 5, and 6. So 6 goes there, no remainder, so nothing goes with a 4, it's still a 4. And then finally, how many times can I count in 2 till I get to 4? 1, 2. So my answer would be 3.62. One of the things that we tend to get as well is a remainder at the end. If that happens, what do we do? Well, in this case, if I had something like 361 divided by 4, this is what I'd do. Dividing by 4 means counting in 4's. So if I'd fill those in, gives me a good place to start. 24, 28, and so on. 32, 36, and 40, stopping at 10 times that number. So the 4 will go on the outside here. I draw my bus stop and write 361. So I now count how many 4's can I count till I get to 3, answer being 0 because it is smaller than that number and I can prove that here. So that 3, I'd write 0, and then the remainder will go with the 6. So I'm now looking for 36 and I can quite clearly see it by here. So that, if I know that's 10 times, then that must be 9 times. Now that's 9 with no remainder, so this is still a 1. So this number 1 is smaller than 4, so that answer must be 0. Now in primary school, our students are being taught to write that as R1. And we're going to try and use that technique to help us here, but go a little bit further. Our students know that after hundreds, tens, units comes a decimal point. So we can add in a decimal point here and here. And we know that after a decimal point, the number 0 is just repeatedly there, as many times as you like. So that remainder 1, instead of getting written up there as a R1, we're going to write as a remainder 1 by here. And now we're looking how many times can I count in 4 till I get to 10, which is between 8 and 12. So that is 1, 2, 2 and a bit. So 2, I was looking for 10, I got to 8, so that's a remainder of 2. So that remainder of 2 comes here. Now it looks like there's nothing there, but as we just said, after a decimal point, we know there's loads of zeros, so I can add in another 0. So that's not really a 2, it's a 20. And finally, counting in 4s until I get to 20, I can count 1, 2, 3, 4, 5 times. So my answer is 90.25.